So we talked about how integrals give us the area under a curve, and we can see why if we draw. Well, we can see why this means there's a limit of some sum if we run with this idea. So if we have some graph with x here, y here, and this is some function of x, and then to find the area under the curve, what we can do is at each point we can draw a little rectangle at the height of y of x at that point, and add up these rectangles to approximate the area. Okay, so we can keep going like that. So in total we'll have n rectangles, okay, some finite amount of rectangles. Note that if we plot an individual rectangle, y of x, we're going to call the distance, we're going to call that delta x, and that's a constant. Each rectangle is the same width. The point at which we start the rectangle x of k, and this value here, so therefore the length of this line is y of x of k. Sorry, that's so small, but anyway. So the sum of all these rectangles is equal to the sum from k equals 1 up to n. We'll say from k equals 0, where this is x to the 0. Okay, from k equals 0 up to n of, and the area of these rectangles is y of x of k multiplied by delta x. So if we want to add more and more rectangles, that's equal to, when n tends to infinity, and we know that gives us the exact area under the curve, and what also gives us the exact area under the curve is the integral. So therefore the limit as n tends to infinity of k equals 0 up to n of y xk dx is equal to the integral from b to a of this y of x with respect to x. Okay, obviously on some specified region. So hopefully you can see how integration is the limit of a sum here. If you didn't understand any of this, a brief explanation, then let me know in the comments and I'll try to clarify any issues for you. But for now, that's it. Thanks for watching, and I hope to see you in the next one.